Hey guys, you are watching Physics Slide, and today we are going to discuss TIFR-2018 physics problem. Okay, the question is, an electron enters a linear accelerator with a speed v equals to 10 meters second inverse. A vertical section of the accelerator tube is shown in the figure. So you can see the figure. It has lots of sections and it is a vertical tube. Okay, where the lengths of successive sections are designed such that electron takes the same time t equals to 20 milliseconds to traverse each section. So no matter what the length of the section is, for each section electron is going to take the same time, that is t equals to 20 milliseconds. In 20 milliseconds it is going to cross this section and enter the other section. Okay, and next, if the momentum of the electron increases by 2% every time it crosses the narrow gap between the two sections, what is the length in kilometers of the collider which will be required to accelerate it to 100 kilometers second inverse? So while the electron is passing through the narrow gap between these two sections, its momentum is going to increase by 2%. So by the end of the tube, the velocity of the electron is 100 kilometers second inverse. We have to find out what is the distance traveled by the electron before achieving this field or a desired value of velocity. Okay, this is a very interesting problem. Very little physics involved, but more mathematics is involved here. Okay, let's get started. So let us say this length of this section is d1 and this length be d2, this length be d3, and so on. There are lots of sections like this, and we have to find the total distance traveled by the electron before achieving the velocity of 100 kilometers second inverse. So okay, our job is to find out d, that d is d equals to d1 plus d2 plus d3 and so on up to, let us say, suppose there are n sections and distance traveled will be dn. So okay, and here we are going to write this distance in terms of velocities and time. Okay, this is v1 into t plus v2 into t plus v3 into t plus so on. And why have I taken a t instead of t1 here, t instead of t2? Because it is given in the question that the electron takes the same time t equals to 20 milliseconds to traverse each section. So the time will be constant for each section. Okay, so we are going to take that t out, and it is v1 plus v2 plus v3 and so on up to vn. Our job is to find out what this sum is, and our problem will be done. But this is not an easy task. For section 1, they have given the velocity v equals to 10 meters second inverse. But what about the other sections, v2, v3 and up to so on vn? We don't have any information. So what are we going to do now? If you carefully observe the question, they have given something in the question. The momentum of the electron increases by 2% every time it crosses the narrow gap between the two sections. Okay, so using that we are going to find out what this sum is. And how am I going to do that? Let's see. Okay, see, suppose while entering the first section, let the momentum be p. In the first section, let the momentum p equals to p1, say. While entering the second section, its momentum increases by 2%, that is p1 plus 2 by 100 into p1 equals to p1 1 plus 2 over 100, and this is p2. And what happens to p3? The same thing happens, p2 plus 2 by 100 into p2. It increases by 2%, right? p2 into 1 plus 2 over 100. This is p3. But from equation 1, we have p2 equals to p1 into 1 plus 2 by 100. Okay, we are going to substitute this p2 value here. Okay, what are we going to get? p3 equals to p1 into, there is already 1 plus 2 by 100 here, and this will be another, so it will be square, 1 by 200 whole square. So you can already see that the momentum increases in geometric progression. So P equals to P1 for first section, and for second section it is P1 into 1 plus 2 by 100, and for third section it is P1 into 1 plus 2 by 100 whole square. So this is in geometric progression. But how we need the velocity? They have given the momentum. So how are we exactly going to find the velocity? Here lies the trick. Because the mass of the electron is constant, we can write, see, suppose for P3 we can write m into V3 equals to m into V1 into 1 plus 2 by 100 whole square. So this m's nicely get cancelled out, and we get the velocity V3 equal to V1 into 1 plus 2 by 100 whole square. So given the momentum, velocity is no big deal, we can find out. If the momentum is in geometric progression, velocity will also be in geometric progression. So v1 equals to v, say v2 equals to v1 into 1 plus 2 by 100, v3 equals to v1 into 1 plus 2 by 100 whole square. So if we are going to substitute these values in this equation, what are we going to get? D equals to T into V1 plus V1 into 1 plus 2 over 100 plus 1 plus V1 into 1 plus 2 over 100 whole square, plus and so on. Okay, so this is the last step, and I'm going to start from here. So D equals to T. We have to take V1 common out of this bracket, and we'll get T into V1 1 plus 1 plus 2 over 100 plus 1 plus 2 over 100 whole square, and so on up to n terms. Okay, we are going to find out this sum. Okay, this is we have n terms like this, so we just have to sum all these terms. So what is the formula in GP for sum of m terms? It is Sn equals to a into r to the power of n minus 1 minus 1 divided by r minus 1. And what is r? It is a ratio. That ratio is V2 by V1 or V3 by V2, etc. Okay, and that ratio is, as you can see here, 1 plus 2 by 100. R equals to 1 plus 2 over 100. We are going to do that. So D equals to V1 into T. What is the first term here? That is 1. 1 into r to the power of 1 plus 2 over 100 power of n minus 1 divided by r minus 1. R is 1 plus 2 over 100 minus 1. These are going to cancel, and V1 and T, we have these values. What is V1? V1 is a 10 meter second inverse, and the time is at 20 milliseconds. If you multiply 2, we will get 0.2 meters. Okay, and D is 0.2 into 1 plus 2 by 100 power of n minus 1 minus 1 divided by 0.02. Okay, now only thing we are unfamiliar with is what is the n here. We are going to find out this term 1 plus 2 by 100 whole to the power of n minus 1. And how are we going to do that? And I must remind, what is the nth term formula in GP? In GP is nth term is an equals to a1 into r to the power of n minus 1. So if the velocity is vn, it is v1 into r to the power of n minus 1. This vn is our desired velocity, that is 100 kilometers second inverse, as given in the question. Okay, converting it into meters, we'll get 10 to the power of 5 is equals to v1 10 kilometers and r to the power of n minus 1. This r we know, this r is 1 plus 2 by 100, so it is no big deal. So 10 to the power of 4 equals to 1 plus 2 by 100 power n minus 1. So we have this term 1 plus 2 by 100 whole to the power of n minus 1 is equals to 10 to the power of 4. I'm going to substitute 10 to the power of 4 into this, okay, and now the d becomes d equals to 0.2 into 10 to the power of 4 minus 1 divided by 0.02 equals to 0.2 0.02. This is 10 to the power of 4 minus 1, approximately 10 to the power of 5. This is meters, but they have asked in kilometers. Okay, the length in kilometers, so we have to convert this into kilometers. D is equals to 100 kilometers. This step is very important, guys. Please don't forget. I lost 2 marks, no 5 marks in TIFR exam by forgetting only this step. I did all the problem, but I forgot this step. So our problem is done. What have we done? Basically, we have to be familiar with the geometric progression formula and apply little logic that if the momentum is in the geometric progression, velocity also will be in a geometric progression. So this is how you solve the problem. Tomorrow I'll meet you with a new problem. Okay, good night, take care, bye bye.